section. I'm super excited. Felix and his entire team at Dartmouth are just an absolute visionary customer we've had, and I'm so thankful. Thank you, Felix, for joining.
Yeah.
Your slides are queued up, so I'll shut up.
Thanks. I guess just for introduction, so I run the networking team at Dartmouth. We're a university up in New England, about 5,000 to 6,000 undergrads, some grad students. We have 3 professional schools attached, a school for business, for medicine, and for engineering. And we do everything that has to do with data and voice on that campus. So that's wireless, up to the internet, all the phones, TV, and so on. Just, I guess, I'll only take 30 seconds on this because maybe most people know, but this way maybe things make a little bit more sense. As far as that environment goes, it's kind of interesting in that we are 99% residential. So virtually all students live on campus, particularly the undergrads. So we have a very interesting mix in the kind of problems we have to solve because, right, on the one hand, you have students who literally live with us for 4 years. We're their home. So their PlayStation has to work, Stranger Things has to stream in 4K on Netflix, right? It's the usual home stuff. But on the other hand, you have the medical school now does virtually all of their testing online. When somebody after 6 years of trying to become a surgeon is taking a final exam, what they really don't need is Wi-Fi problems 5 minutes before that starts, right? That adds a little bit to the pressure of that day that is already pretty bad for them. Similarly, we have tons of just random devices, right? We've got electron microscopes. We've got fMRIs streaming massive amounts of data. We've got, in the med school and the biology school departments, you've got tons of freezers with cultures in it that are literally somebody's, there's a federal grant behind that research, right? This is 3 years of their life. And if that fridge goes offline and doesn't tell you that right now your cultures are dying, that's a really, really bad thing. So it's kind of a little bit of everything, and it's kind of the ultimate BYOD. Januaries are great when students come back from winter break and they get all the presents at Christmas and bring them back. We get to connect them to our network, which is definitely interesting. I guess briefly for background, so even though that is a manager role, which I am now, that's relatively recent. I used to be the lead network engineer for Dartmouth. One of the reasons I transitioned is we started building a new network. We had a fairly old legacy campus network built on wireless controllers that were more or less designed in 2011, 2012, right? Which in the wireless world is more or less Jurassic kind of era. And a pretty standard just collapsed core network, a little bit of VRF light sprinkled in, which gets a nightmare to manage after a while. And we basically said we want to build something greenfield. I helped architect that, and then my boss decided to retire, so I decided to take over for him so I can make sure we built this the right way, instead of somebody letting somebody ruin it, so to speak. So Dartmouth, we're kind of old. We're reasonably high ranked. We always have to put this in here. What's really interesting is we are actually the birthplace of AI, and that's more or less verified. The term artificial intelligence was first used in a paper called back in, I think, 56 for the Dartmouth Summer Research Project on Artificial Intelligence. If you look that up, that's people like Shannon and Weaver, Marvin Minsky, and so on. And the first time the actual words artificial and intelligence were put together were kind of for this symposium. So it's kind of nice to come wrap back around to actually now deploying this kind of stuff on our network. So we are obviously, wireless is the primary access method, right? If you look around and you ask a given freshman and you tell them, hey, we've got this application through which you have to register wired devices, like register your MAC address to your name. They just look at you like, are you ever going to plug anything in? Nah, my PlayStation at home uses Wi-Fi. I mean, you generally, right, MacBooks don't even have Ethernet ports anymore, neither do phones. Nobody's going to, of the student population, is going to access the network via the wire. So we have a massive increase in wireless users. I started in Dartmouth in 2011. At that time, we had approximately 4,000 concurrent devices on Wi-Fi. We're now regularly topping 26 or 27,000. And that's in 8 years. It's really gone up to the point where nowadays, if we design for Wi-Fi, we're more or less counting 3.5 devices per user. And they're actually on. I mean, it used to be that everybody had a laptop, sure, but most people had it closed in their bag. But right, phones pull Twitter updates every couple of minutes. That's just how it works. So the main problem with that was really how difficult controller systems are to troubleshoot. I mean, some credit to vendors that run large controller-based architectures. They do try to give you management tools to make that easier, but at the end of the day, you can't take a frontline service desk person and expect them to understand how to drill into these logs or SNMP traps, or often it doesn't even correlate like DHCP and radius or whatever. I can't expect them to know everything about how to fix any given printer, how to set up antivirus, and go and troubleshoot detailed Wi-Fi issues. That's just a no-go. So what that means is that tickets get punted along, and those tickets make it through and they get solved, but you're essentially eating up often the main wireless guy. Brian's our main wireless guy. I don't need him working on somebody just having upgraded their Android phone to a firmware that isn't compatible with Wi-Fi 6, and that's why it's dying. Right? That's not a good use for him of his time to spend on one user for hours, to solve that ticket. So on the wired side, our main problem with the prior network was basically everybody here probably knows it, not probably, everybody here knows this. Once you have a network that you upgrade piece by piece for 20 years, you've got more one-offs than you have what still conforms to the actual standard that you started out with. Usually, particularly in higher ed, stuff comes quick and fast, right? If faculty comes at you and says, I just got a $3 million grant and I have to deliver the first piece of data in 2 weeks, you don't get to sit down and architect something carefully and write pages of documentation on how you built it. You build that thing and you make it work. So that is particularly difficult once you start adding new technologies. And we are a technologically savvy university, so once you start adding stuff onto an architecture that was really built 15 or whatever, how many years ago, you start running into just the issue of just competing priorities that these technologies want, and that's difficult to support. One of our most interesting, probably parallel use case is out of the National Science Foundation. About 5 years ago, I think, there was a project called Science DMZ. Right? As everybody knows, security devices increase latency, right? Because they need to reassemble data streams. They need to, in order to do anything better than just, packet filter kind of technology. So on the one hand, you've got a university network that you need to protect. We do see stuff like state-sponsored attacks and things like that. But on the other hand, if you have research that is completely public, that you genuinely want to make available to the entire research community, and it's terabyte-sized data sets, putting some firewall in there that can do 300 megabits per stream or whatever, right? That doesn't really work. So we basically build a completely parallel network, air-gapped, meeting out our WAN routers, for that kind of purpose. That comes with its own challenges, right? Because now I need to get funding to upgrade 2 networks instead of just 1, and so on. So this is kind of a quick snapshot. You guys let me know how much you care about looking at this. So this would be a good example of a previous building. Sudukov is our computer sciences department. So we have a bunch of just core routers. We started networking the Dartmouth campus fairly early, so our fiber plant is honestly a mess. It's not like you have 2 core sites that everything comes back to. It's all over the place, and you put core routers in those places and interconnect them. That's cheaper than trenching. So right now, most buildings really only have a single, it's port channels, but they go to a single core router. From there, it's collapsed core, so layer 3 resides in the core. And from there, it's just layer 2 down to the actual switches that serve the building, and they also have APs on them. And that's the core hooking up to the WAN network via a couple of, actually these are Palo 5250s. I cannibalized some older slides. So pretty standard kind of what you would find in academia, having talked to a bunch of other schools. We do have a high degree of redundancy on the WAN, right? We have redundant connections. I2, we go via an I2 connector in Boston called Knox, Northern Crossroads. Wonderful people, can't say enough good things about them. And we also connect directly to the I2 backbone via an AL2S node they have in Albany that bridges us through to Chicago and Cleveland. And then a whole bunch of just commodity internet providers, where we try to play nice, and we basically just say, I2 RNE, prefer that when you learn it via BGP. Otherwise, prefer commodity internet and only go over to CPS when you absolutely have to. We also peer directly with Dartmouth Hitchcock Medical Center, which is the regional trauma center and a teaching hospital in New Hampshire. So this is what we came up with okay, so actually, before I go to that. So we said this is no longer good enough, and we'd like to build something new. And really what we came up with is that we want to act as a service provider in the sense of, right, I was talking about the mismatch between building something where funding cycles are fairly long-lived, and you have to build something that lasts for a long time, but where at any given point in time, somebody can throw completely new arbitrary technology on you and say, make this work. So we figured the best way to approach that would be what service providers have been doing for a while, and just build some sort of, like a backbone that is able to provide layer 2 and layer 3 VPNs. And then we can attach whatever we want to that. At this particular, we went greenfield with that. We decided we've now upgraded in pieces the existing network for long enough. We're just going to basically run that, build something new parallel to it, migrate over building by building, and be done with the old thing. That way we're not restricted by legacy technology that we have to support. So we're currently building that. There are buildings in production, but we're not done cutting over the entire campus yet. Given just the time right now, we went with EVPN VXLAN, simply because that's reasonably cheap to buy nowadays. So this is kind of what we came up with. We have a bunch of core routers. We have some services gateways that actually bridge between the various VRFs. They can either directly bridge into an internet VRF or do this via layer 7 firewalls. Distribution routers, that's where the layer 3 interfaces for all of the VLANs live, and then we go down into just virtual chassis of EX3400s in buildings. We've since adapted this a little bit, so we're actually going to build wireless switch stacks that just serve for AP uplinks, and the wired data connections you have as jacks and rooms separately, because we estimate that so we finally managed to get our funding model to a point where we're going to be able to upgrade our Wi-Fi every 4 to 5 years. I'm ridiculously pleased with that. I'm still running APs that were Cisco AP 3500s, right? They're old. Like, we're at the point where 8.5 is kind of like the last controller release that actually still supports them. I can't go beyond 8.5. I'm going to lose literally 30% of my still existing legacy APs. That's an absolute nightmare. And that is way too old. You can't have students, freshmen in a classroom on an AP, and the AP was manufactured closer to their day of birth than today, right? There's something wrong there. Like, their parents are running newer gear at home. So because of that, we figured we'd put the APs on switches that are dedicated to them. That way we can kind of upgrade those faster and don't have to just, you don't need more than a gig for a printer somewhere in a hallway. And that EX3400 can sit there for 7, 8, 9 years. So really what we started with is 2 ideas. First of all, that service provider scenario, but also we wanted to go hard on automation. And when I say automation, like we've heard, right, everybody means different things by that. What I mean by automation is increasing the reliability of change, period. Automation should help me to make changes to the network configuration where I am highly confident, above 90%, that it is going to have the desired effect and only the desired effect. Kind of to Bob's example of, right, somebody changed MTUs and that screwed up radius. I should be able to make a change to the MTU on the router interface and have something tell me whether or not that is going to screw up other things. That has some really nice side effects. Once I have made a specific change so reliable that all I need to do is feed some input into that process, and I can be really, really confident that it's going to do the right thing, I can basically look at how difficult is the input. If the input is fairly easy to construct, why should this go to network services? If this is as simple as saying, I would like this switch port, or rather this jack in the wall, they don't even need to know about switches. I have a jack in the wall, and the jack ID is XAA1. It's printed right above it. I should have some sort of mechanism of saying, I want this port to support a printer, a public IP address, an AP uplink, whatever other templates you want to define. That is input I can absolutely give to my service desk, right? anybody who can troubleshoot any IT tickets for other users can work with that. That doesn't mean that I don't want to do the work anymore. Obviously, if they're too busy, they are more than welcome to open tickets for that, and we'll do it. But this also really increases customer satisfaction, because now somebody wanting to install a new printer in their office doesn't go to the help desk and then gets told, oh yes, I'll open a ticket for you, and network services will get back to you within 48 hours. It is simply, okay, done. Away they walk, and it actually worked, because we can be so confident that the change we just made actually had the intended effect. Similarly, that kind of brings us back to that whole self-driving versus driver assist, right? Once I am really supremely confident that the input I'm giving to a process is actually correct, then why wouldn't I let that process run by itself? What's the value of some machine spitting back a log, like analyzing some log file, sending me an email and saying, here, you should effectively, it'll say this differently, but effectively say, go to this web page, copy and paste this specific value into the text field and click submit. Why would I insert a human into that, right? This doesn't work for all changes, obviously. Like, we probably would never create new VLANs via this kind of mechanism, just because the average user doesn't know what kind of subnet size to choose or whether or not they need DHCP, right? We don't want people trying to figure that kind of stuff out. But when it's genuinely about changing the template on a jack, or deploying a guest wireless SSID in some specific area, those kind of inputs are so simple that you can either self-feed it or kind of democratize it and delegate that work to other people. The other thing we are interested in, we are just cards on the table, we're not particularly far down that journey, is location services. This is less interesting than you might think, actually, for students. Like a map to show you where your classroom is helpful for a freshman who's there during the first week. But with our experience from other ways to make it easy for them to find their way, after a week that drops off, because at that point you kind of know where your dorm room is, you know where the classroom is. Why would you bring up an app with a blue dot to watch yourself walk? That's not interesting. Nobody runs Google Maps in order to get to their local grocery store, right? You just don't. Yeah.
One of the coolest demos that I've seen in the last couple of months has been student IDs, panic buttons. Basically, we live in a terrible time with regards to that. But is that something have you considered the security implications of doing location services, and if so, to what extent?
We're hoping to tie this in at some point. We actually have an app at Dartmouth where you install an app on your cell phone, and you can actually ask a friend to track you. So if you have to walk across the green at 2 a.m. and you're feeling uncomfortable with that, if you have somebody that you trust, they can actually just basically acknowledge a notification that they're now not responsible. I don't want to say responsible here, but right, that they've been asked to track whether or not somebody makes it back home, and they would then be able to escalate to security, et cetera. So being able to get more location data into that would absolutely be huge. Other use cases there are simply, and this sounds kind of silly, but campus tours. Right? During that season, at Dartmouth, they affectionately call it the flamingos, because you've got large groups of people doing this. Those are, right, you walk somewhere, you stop, and then a student tells you all about the, dining hall that you're standing in front of. What would be really interesting there is making a companion app for that actually streams in multiple languages. Because what we see quite a lot is international students only half listening to the tour because they're too busy translating it for their parents, whose English might not be good enough to actually follow what the tour guide is saying. Like there's tons of out there applications. Same for like finding books in the library. Right? That is a use case that doesn't go away like it does with getting from your dorm to your classroom, because that's always the same path. But where the book is among those millions of stacks, right, that actually changes every time you pick up a new book. That would be interesting to do. Where, side note, library stacks. Oh my God, why find library stacks? If you've never done that, don't. It's, right, books are great at blocking signals. So a really interesting use case there is actually Mist virtual beacons, where you might, like one use case we came up with would be, let's say you've got the chess club that usually meets in, I don't know, Robinson 102, but that level is getting renovated right now, and for 3 weeks they have to move. Like, let the actual president of that student club throw in virtual beacons so that somebody who's also in the club and he walks into Robinson at the time it usually meets, they just get a pop-up saying, oh, hey, actually today we're in the building next door. Here's how you get there. Like those would be kind of interesting things to do. Any questions? I guess I am the use case. So if you've got, if you've got like, for example, just, I can't not say this. As far as the whole question towards storing all that data. What this basically meant for us is that when we sat across Tom, the VP of sales, he wouldn't budge on points on the actual license cost for Marvis beyond a certain point. It's not actually, yeah, you don't see that. We do, I guess I should really talk about that, sorry. I'll take 3 minutes. Marvis is huge for us. Originally, when we went with Mist, one of the things we were trying to get rid of is the central controller kind of thing, where right now we have a bug on the legacy APs we're still running, and that's been going on for 2 months. We were just watching logs, and literally when certain logs appear, we reboot the controller to fail over the HA pair. That's been going on for 2 months. And the new firmware has been announced, and we'll not be able to get it until the end of this month. With Mist, we can upgrade to arbitrary AP firmware revisions, and we've received fixes for bugs in a matter of days or weeks. And also, just as a testimonial, we have gotten calls saying this AP is bad. We would like you to RMA it, before we knew that that was going on, because no user had actually reported it. So originally, we thought Marvis, that's a nice gimmick. We weren't sold on that. We were going to Mist for different reasons. Since then, my lead wireless engineer goes to Marvis for every ticket that makes it up to him. And he says in more than 3/4 of the cases, the first thing that it lists is the actual answer. In a significant amount of others, it's number 2 or 3 from the options that it lists. Sometimes he has to dig in deeper, that has gone way down. Yeah. Yeah. We're so close. Similarly, just because I talked a little bit, we have 3 professional schools that have their own IT staff, just because they're very, like a business school has different IT needs, right, than some liberal arts undergrads. So they run their own IT teams, and we used to get tons of tickets from them, right, because they were blind. Even if we'd given them access to the controllers, they didn't have the expertise to handle that or interpret that data. Mist has since come on site for us and has actually trained those IT service desks, and the number of tickets has gone down rapidly. And the tickets that we still have actual actionable, like it's not just Bob says Wi-Fi sucks in this room, can you look at that? It's here's what we've looked at, here's the packet captures, here's what we've already ruled out, we still don't know, can you help? Which is, you know, just hours off of the whole thing. That whole dynamic packet capture thing is ridiculously cool. Like you go back a week and somebody said, oh yeah, by the way, I had to leave for a conference, but on Monday stuff sucked over there. Here's a packet capture. That's awesome, I've never seen that before.